All right, let's jump right into this explainer and uncover the mind-bending geometric magic that happens when we simply change the center of our world map. For our entire lives, practically all of us have stared at the exact same standard map of the world, right? It's got the equator running perfectly straight across the middle, the North Pole anchored at the top, and the South Pole down at the bottom. It feels totally fixed, absolute, unquestionable. But today, we're going to challenge that assumption using a bit of geometry and a brand new perspective. Let's see what physically and mathematically happens when a country decides to tear up the rulebook and put itself right dead center. So, I want you to start by just asking yourself this. If we center the world map on your exact country, where does the actual equator go? Just imagine completely breaking our traditional view of the world by centering a map on your own hometown. You might intuitively expect everything to look perfectly normal, just kind of shifted left, right, up, or down a little bit. We tend to think of maps like a flat sheet of paper that we can just slide around on a desk. But geometry has a massive surprise in store for us here, because we aren't sliding paper around. We are dealing with a sphere. And when you change the center point of a 3D sphere and then try to flatten it out again, the fundamental shapes of our world go through a really radical transformation. And what's really fascinating about this transformation is just how dramatic it actually gets. Take a look at this. That blue line you see crossing the map, that is the true equator, the traditional equator we all grew up with. But notice how it violently distorts into a giant wavy curve? You can see it dipping way down through Africa and sweeping back up. Meanwhile, our new custom center line, that red line spanning straight across the middle, becomes the perfectly flat horizontal axis. This isn't a glitch, it's a mathematical certainty called an oblique projection. By placing a new arbitrary line at the very center of our flat map, the actual equator is literally forced to warp. But why exactly does this happen? How does a perfectly straight belt around the Earth turn into a giant wave? Well, to wrap our heads around this illusion, we first need to lock down a concept called a great circle. Think of a great circle as basically any hoop you can draw around the Earth that perfectly slices through its absolute core, splitting the planet into two totally equal halves. The original equator is a great circle, but so is a line that cuts straight down through the North and South poles. In fact, you can draw an infinite number of great circles around the globe at any crazy angle you want, just as long as the plane of that specific circle passes directly through the exact center of the Earth. Which brings us to a rock-solid rule of geometry. Picture grabbing a physical globe in your hands right now. If you draw a new equator-like ring around it at a tilted angle, your own custom great circle, the rules of a sphere dictate that it absolutely must cross the original equator in exactly two places, no exceptions. And those two intersection points, they will always be on exactly opposite sides of the planet, exactly 180 degrees apart. Because they share that same core center point, they have to cross. You literally cannot have two different great circles that don't intersect. So what we are really talking about doing here is fundamentally rewriting the math that governs our maps. We are essentially upgrading our whole mathematical perspective. We're moving from an original system where the traditional equator is the flat baseline at z equals 0 to a new customized coordinate system where our chosen great circle completely takes over as the central y prime equals 0 line. It's kind of like taking a giant mathematical grid that's locked onto the Earth, detaching it entirely, and just spinning it around so that a totally different line becomes the new 0 point. This brilliantly illustrates the 3D reality before we even try to flatten it out into a map. You can clearly see the blue line representing the traditional equator, and then there's the green line, which is our new custom-chosen great circle. Look at how they cross each other at a distinct tilted angle, meeting at two exact points on opposite sides of the sphere. Now, on the physical 3D globe, they are both just perfect flat hoops. Neither one is wavy, neither one is distorted. They are just two rings, tilted away from each other. But to actually make our country-centric map, we have to change the math. Watch how the axes of the sphere itself adapt. We are physically rotating the entire mathematical coordinate system so that our new green circle acts as the equator. We're taking the original x, y, and z axes and we are twisting them. We're essentially grabbing the poles of the Earth and mathematically tilting them so that our chosen green line lies perfectly flat. So here's the absolute crucial point to remember throughout this explainer. The physical planet hasn't changed shape at all. Only our mathematical perspective has shifted. The actual geography of the Earth remains absolutely identical. The distance from your front door to the nearest ocean, exactly the same. All we've done is change the mathematical lens through which we project that 3D sphere onto a 2D plane. We've just decided that a different ring gets to be the VIP straight line right in the middle of our paper. But that VIP status comes with a visual cost, because our newly chosen centerline is now forced to be perfectly straight when flattened onto a 2D map. The original equator is mathematically forced to wave up and down across the grid. This dramatically shifts places like the Amazon, Ethiopia, and Indonesia. They are no longer just strung out along a flat horizontal line in the middle of the map. Instead, they ride this giant, sweeping sinusoidal curve. They haven't moved an inch on the Earth, but they have radically moved on the map. Now, how do mapmakers actually pull this off? You definitely do not need to memorize the math here, but it's super fascinating to see what's under the hood. There's a 3x3 rotation matrix acting as the engine, calculating the exact new warped position for every single point on Earth. When cartographers plug the original latitude and longitude of a city into this matrix, it spits out the brand new coordinates, the new x prime, y prime, and z prime that perfectly align with our new tilted perspective. It's just this elegant piece of math that recalculates the entire planet in an instant. Moving right along, let's look at Section 1, Applying the Math for a Sol-Centric World. Let's make this totally concrete and see how this abstract geometry builds a tangible map by centering everything precisely on Seoul, South Korea. We take the exact coordinates of Seoul, right? 37.57 degrees north and 127.0 degrees east. By mathematically setting a great circle that runs straight through Seoul as our new y prime equals 0 baseline, Seoul is anchored perfectly flat across the center of our new map. And because of those great circle rules we talked about earlier, whatever point is on the exact opposite side of the globe from Seoul will also align perfectly on this new straight center line. And the visual result? It is absolutely stunning. Making Seoul the geometric star of the show pushes the once straight traditional equator into a massive arching curve. Look at that red dotted line. That is the traditional equator. Because Seoul is up in the northern hemisphere, tilting the globe to put it on the center line means the equator gets shoved downwards and bends dramatically, creating this giant dome shape across the projection. It completely reorients how you view the global south and the tropics relative to South Korea. And here is a wild fact that almost always gets overlooked. This rotation doesn't just bend the equator, it actually kicks the original north and south poles completely out of their standard top and bottom positions. They get shoved into entirely new corners of the map. If you tilt the entire globe's axis so that Seoul is at the equator, the North Pole has to lean far away from the top edge. The traditional top and bottom of the world are just completely redefined. Which brings us to a really powerful realization. The quote here perfectly summarizes our whole journey today. Setting the central horizontal axis to a chosen great circle is the mathematical principle of a country-centric world map. It sounds like just a bunch of math jargon, but it's actually a profound concept. By simply redefining what we call the centerline, math empowers literally any nation, anywhere on the globe, to logically and geometrically place itself at the absolute heart of the world. So I'm going to leave you with a fascinating thought to ponder long after this explainer ends. We've seen how easily a 3x3 rotation matrix can twist the equator into a wave and throw the North Pole into the corner. But maps, they're more than just math. They actively shape how we see our reality. So if mathematically shifting a map's center completely distorts our physical view of the equator and the oceans, how does it alter the way a country sees its own power, its trade routes, and its place on the global stage? By putting yourself at the center, the rest of the world quite literally revolves around you. It's an incredible reminder that sometimes simply shifting your perspective changes absolutely everything.